Thank you. Now, let me welcome the next speaker, Dr. Sunita Purushottam, a highly driven, enthusiastic, people and results-oriented, knowledge-driven professional with a demonstrative track record of experience gained in international and national projects in different sectors in response to the challenges of environment and sustainability. Today, he will be touching on this topic, sustainable buildings and construction for climate action. Let's welcome Dr. Sunita Purushottam, Head of Sustainability at Mahindra Lifespace Developers Limited.
Thank you so much for the opportunity. So I am Dr. Sunita and I head sustainability for Mahindra Lifespaces. We are a real estate company in India. We have operations in Bombay, Pune, Delhi, Chennai, Bangalore. We are also into industrial clusters and integrated cities. So we understand all aspects of the built environment. So today's discussion is around sustainability in the built environment and what are the kind of opportunities it poses in front of us. I will also talk about climate change and the impact on Indian architecture then and now, revisit construction practices from the sustainability lens, and how organizations in the built environment can take up commitments to tap into the unprecedented opportunity that actually climate change presents in front of us. So that is the main, these are the main aspects that I will be discussing today. So temperature has changed in the last 50 years, and we really see that we are moving towards, we won't be able to meet 1.5 with business as usual. So restricting the temperature rise to 1.5 degree. So business as usual is saying that there are pathways that are going to take us to 2 degree, 3 degree pathways. So the trend that we have seen over the period of time is, these are data for, so the average temperature of Earth is 14.1, and we are looking at, already capping it at 1.2. That is the kind of temperature rise that we are seeing currently. Of course, it affects us and it affects business. In terms of human life, it affects thermal comfort and well-being. It also costs us building operations. It also costs us resilience of the built environment. So the rainfall patterns and the availability of water, climate change actually manifests as in form of water. So it's either too much and or too less. And if it is too much, it is in sudden spurts. So that has an impact on the food security of the planet. So these are business impacts. These are impacts on everybody's health and happiness, and therefore needs to be looked at very deeply. The point is that Indian architecture respected climate, and therefore some of the buildings that you see on the screen right now showed how we could integrate in hot, humid, in in the hot and dry climates, what kind of buildings and structures we used to traditionally make. So traditional vernacular buildings were climate responsive. They had passive heating, cooling, and low energy use, and very, very selective use of air conditioning systems. Modern buildings, however, use a lot of glass, use concrete, and therefore have led to, they emulate the Western architecture. They are high tech, they are energy intensive, and no matter what amount of technology you put on top of it, they are energy guzzlers. So buildings contribute to 40% of the built environment, contributes to 40% of greenhouse gas emissions. And if that is the sector that we are not able to, mitigate in terms of climate, in terms of carbon emissions, the impacts that are going to be felt are runaway impacts. Okay, so let's see more about then and now. So office buildings, we look at smaller windows. Now we are looking at more full height windows. These are shaded marketplaces. Actually, we see them in Delhi, we see them in Bombay. But now we look at large unshaded windows and more of car parks. So thicker walls, now we have Maivan structure, which are absolutely pure poor performance walls. So these are some of the differences between the architecture of then and now. The main difference also has been that we have moved away from locally available construction material and methodology of climate responsive design to actually uniform buildings all over the place. So any building in Delhi can be similar to a building in Bombay, and a building in Bombay can be similar to a building in Bangalore. And you actually stop differentiating a place from one another, because there is no architectural difference in the buildings that we are seeing in large cities. You can be in Boston, or you can be in New York, or you can be in London or Bombay, and you may not be able to make out, okay, where am I? Because the building is actually similar. It is a glass facade, it is on a steel concrete structure. So the idea here is to bring back something which is called as climate responsive design. And how do we do that? So the business as usual piece will, lead to a lot of energy consumption. And what we are looking at is without climate responsive design. So this is actually going to lead us to avoided emissions. So we look at reducing the energy requirement in the first place by designing for least possible air conditioning and no artificial lights during the day. Minimize the heat gain, the amount of heat that gets into the building. And there are two main factors, like I'm saying, it is the wall and the glass that gets the heat in. So, and the way we improve daylight and natural ventilation potential within the home. And then move on to efficient systems. And many of the efficient cooling and lighting systems, we know that government has successfully run the scheme on LED lights. Where every home now has LEDs, and offices also have embraced LEDs. There is one more scheme that is going on, which is around BLDC fans, brushless DC fans, and these are some of the active measures that we need to adopt before embracing air conditioners, because they have added carbon emissions associated with the refrigerants. So that needs to be understood. Once you minimize the energy load, the amount of renewable energy that is going to be required is going to be very, very less. And if you don't do CRD, your cost of renewable energy increases. The other thing is that most buildings will not be able to offset everything on site, and therefore grid renewable energy is important. So getting to net zero is actually the strategy that buildings in India should be following. Okay, so we have actually codified this approach, and this is through design. We use strategies such as avoid, orient, shade, insulate, reflect, zone the building, look at the window shading, and sizing. Sizing is very important. You don't need full length windows in India. Remember, we are not in Toronto or London, we are in India, and the climate here is not amenable to full glass windows. The other is opening and the openings and the wall and roof materials. Extremely important that we look at wall and roof materials when it comes to constructing better buildings. That's the first step. So now you come to the next part of the story, that now you know that your design is good and you have it on paper. So how should the construction be? It should, of course, be sustainable. So ensuring sustainable construction, I tried to break it into 8 or 9 basic things that we need to preserve the topsoil. Topsoil is the fertile soil which takes a lot of time to get generated, and it also is a carbon store. So destroying this topsoil means that we will have to buy it from somewhere else. And one of the planetary boundary challenges that we are facing is topsoil contamination with fertilizers and pesticides. So this N and P problem that we have for soil needs to be therefore saved. And most construction sites which have vegetation, and it is through clearing of vegetation, we need to actually take the topsoil and preserve it. Okay. The next one is that site drainage for water movement, and of course, sedimentation tank for water percolation. Topsoil drainage, how do you look at the area around the topsoil, and mulching for topsoil. So these are some of the soil erosion control measures that we need to put in place. Trees and biodiversity protection is important because a mature tree needs to be protected, and many times design needs to work around the biodiversity and the rich tree cover of a particular location. And this is something that we have integrated into the design process. So the design process goes through a biodiversity assessment, like we have done climate responsive design. We do a biodiversity assessment and then superimpose, okay, what is the structure that is going to be created? And what are the key sensitive areas? Does it have a IUCN or a heritage tree? And then we work around those. Okay, so barricading trees after, now suppose we are retaining it. Many construction sites, they pile up against the trees, but we need to fence around the critical tree locations. These are irrigation around trees, and how the entire construction site should have downlights, not uplights. Now, protecting lakes, water bodies. These are some of the things around barricading the water body to prevent the dust and pollution, and it should be continuous around the lake. Construction waste management is another key aspect, and the thing that we propose here is alag karo. Alag karo is separate things out, segregating the waste into various categories. And every site should be able to, we should be able to label and figure out, because if you have a mixed category, it is very difficult to recover value. Hazardous waste should definitely be kept separately, and we have a separate process for e-waste management. Site logistics is key, and any construction material on a site which is well managed and stored in designated areas, it actually helps in faster construction and also safety. Barricading, site safety is linked to a process called 5S, where sorting, segregation, standardizing, signage are all part of construction site management. Air pollution prevention. These are many of these images are from the locations that we operate. This is in NCR region, that is the National Capital Region, where we are sprinkling the site to irrigate the site with recycled water. Fuel consumption for at construction site. This needs to be also, we need to move towards this, where we're looking at alternative fuels for DG sets, EV powered machinery if possible, but this is a little far off. Use of solar for construction sites, and that too portable solar, is another aspect that is still not in practice but needs to be put in place. So I had the opportunity to be part of COP27, and I'm just back from Egypt. And we shared the unprecedented opportunity for commitments leading to action, right, in this sector. So what are the kind of commitments that we have? So we have science-based target for our scope 1, scope 2, scope 3 emissions. And we also, on top of it, so this is the SBT is applicable for our operations, offices, sales galleries, and the construction sites. And the net zero target is for the product, that the buildings and the cities that we are making. Green Army is a mechanism for sensitizing our employees, our community, so that they, the young children, this is targeted towards young children-led intervention for behavioral change in adults. So this is a unique program. And we believe that if we are able to create this army and plant a seed in the younger generation, we would be we have more caring citizens who take sensitive decisions while leading their lives. Okay, so these are the other commitments. One of our locations is zero waste to landfill certified. It is a city, India's first city to be zero waste to landfill certified. We have actually developed India's first net zero building in Bangalore. The project is called Eden. We aim to achieve water positivity by 2030. And this is one of the project Haryali is another of our CSR initiative, as is Manhikal. So these are some of the commitments. We aim to be planet positive. This is our approach of greening ourselves and also while rejuvenating nature. So that brings my conversation to an end. And if there are any questions that people have, they can be shared with me, and I would be happy to answer. Thank you. So last but not the least, there are two initiatives that I can share about. One is the decarbonization charter, which looks at the business charter for decarbonizing the built and the construction sector in India. It has got 6 components. We would encourage people in the built environment to contact us. It could be a contractor, design firm, or a supplier into the building sector who could sign into this charter. The other is the Mahindra Terry Center of Excellence, which is a material testing laboratory where we do research around water, thermal comfort, visual comfort, building envelope studies, and standardization of building materials. So these are the 2 initiatives, and that brings me to the end of the conversation.
Thank you so much. Thank you so much.